Good morning and welcome to today's class. This is brought to you by Open Faith Academy in Otun, Ekiti. And so we are going to be treating agriculture, the subject agriculture today. And our topic will be types and composition of soil. Now, first and foremost, what is soil? Soil is the loose or thin layer on the surface of the earth on which the plants and animals lives. It is the loose combination of inorganic and organic material. Now, what we all know is that every living thing dwells on the soil. Even in the water, we can also find soil under by going deeper into the water. Even in the sea, anything river, there is always a soil putting everything together because the sea isn't bottomless. Now, as I explained earlier, soil is the loose or thin layer on the surface of the earth on which plants and animals live. Yes, not all animals can live in the water, while some animals who does lives in the water also have to come to the land to live. Now, for example, you as an human being, you have to come out. You have to live. You can't live in the water, actually. Yes. Where you live is on the land, and the land is composed by the soil. Yes. Now, and also the plants the plants we plant the plants we cultivate, the crops we cultivate, they are also grown on the soil, and it is the loose combination of inorganic and organic materials. Yeah, there are some things that aren't living biologically, but still they are on the soil. Now, whenever, take for example, when you want to cultivate your farmland, yeah, when you are making heaps, during the process of making heaps, you discover some things in the soil. So we can also say that yes, the soil is composed of inorganic materials and also organic materials such as worms. They can also be found in the soil. Soil is the upper layer of earth in which plant grows, a black or dark brown material typically consisting of a mixture of organic remains, which is clay and rock particles. Yeah, this soil is made up of mixture of organic remains, which is everything on the soil, everything making up the soil are remains, just like ashes. When you burn a material, it later become ashes, from ashes to ashes. Yes, it's also possible. Same thing. Whenever the rock goes through the process of weathering, it also becomes part of the soil. Now, let's talk about the types of soil we are having. Now, soil types usually refers to the different sizes of mineral particles in a particular sample. Soil is made up in part of finely ground rock particles, just as I've said earlier, grouped according to size, and sand and silt, in addition to clay, organic material such as decomposed plant material. Now, there are three types of soil. We have sandy soil, loamy soil, and clay soil. Now, these types of soil, everything I just stated now is quite popular among every one of us, especially those that are in, well, no, or let me say, when we are in primary six or primary school. Each soil type has its characteristics properties. Now, what are the composition of types of soil? How are they composed? How are they How have they be to be what they are right now? What are those things that are in them? What makes them up? Now, for sandy soil contains a high proportion of large particles, which is sound. Yeah, sandy soil contains a high proportion of large particles, which is sound, just like when you go to the desert. Yeah. Clay soil contains a high proportion of small particles, which is clay and silt. And also, loamy soil contains nearly equal amount of sand, clay, and silt. It is the most fertile soil for agricultural purposes. Yes, we all know that. We all know that the loamy soil contains equal amounts. Everything in there is equal. Just as an human being, you have to drink, you have to eat your food, and then you have to drink water. Now, what are the characteristics of sandy soil, loamy soil, and clay soil? Now, one of the properties of sandy soil is that particles are not closely packed, which is they are very loose. They are not closely packed. Sometimes they may, in a way, they may not bond very well. Yeah, let us say something like that, in which they do not stand together. And for loamy soil, particles are closely, moderately packed. They are closely and moderately packed, which is they are a little bit what and moderately what packed. But when we are talking about clay soil, particles are packed together. Now, the difference between loamy soil is that everything is refined, and while for clay soil, it is just packed together. Now, for the air content in sandy soil is really high, while the air content for loamy soil is moderate. Yes, just as the properties, which is also it contains sound, silt, and clay. Same thing as that, is all equal, which makes this the air content is really moderate. But for clay soil, it is low. The air content for clay soil is low. Now, let's talk about the porosity for sandy soil. The porosity for sandy soil is also high. And when we're talking about the porosity for loamy soil is also moderate. And for clay soil, same thing as before, poor, or you can call it waterlogged. Now, what is the water content in this in these types of soil? What are the water contents? Now, for the sandy soil, it is also low, while for loamy soil, it is moderate, and for clay soil, it is high, which is it retains sandy soil retains a little water, while loamy soil doesn't take too much and doesn't take a little. But for clay soil, it takes a lot, or should I say extremely. And the humus content for sandy soil is very little, while the humus content for loamy soil is same thing as always, which is moderate. And while for clay soil is variable. Now, provision of support for plants. Now, the only provision, the what can I call it, the characteristics or the level of provision of support for plants with sandy soil is poor, while for loamy soil is what is very good. You can't just go around and start planting anywhere, just like you just going into the desert. Yes, the desert is composed of a lot of there are humus in the desert, but since there is no rain, your plants won't be able to develop in in a way that you yourself will be happy. Yeah, and so for clay soil, we have only to a small content. The provision of support for plants is only to a small content. And the soil particle in sandy soil is about 80% sand and 20% clay, while for loamy soil is 50% sand, 50% clay and silt, while for clay soil, that is for loamy soil actually, while for clay soil its sand is less and 40% clay and still about 60%, just as it was stated earlier, or just as I stated earlier. Everything is equal for the loamy soil, but for the sandy soil and clay soil, it is a little bit off. Now, let's talk about the soil composition. Soil composition. Now, the typical soil consists of approximately 40% mineral, 5% organic matter, 20 to 30% water, and 20 to 30% air. I'm going to say it again. For the soil composition and the soil consists of approximately 45% mineral, 5% organic material, 20 to 30% water, and 20 to 30% air. Now, mineral matter. Mineral matter are obtained by the disintegration and decomposition of rocks, which is also called weathering. Now, this mineral matter is obtained during the weathering process, which is the breaking down or the disintegrating or decomposition of rocks. And the second thing is organic matter. Organic matter. Organic matter is obtained by the decay of plants, residues, animal remains, and microbial tissues. And some of you also generally know them as humus. Humus, which is the dead remains of plants and animals, and so on and so forth. Now, let's talk about water. Now, water is obtained from the atmosphere and the reactions in soil, chemical, physical, and microbial. In a way, we do know that plants also drinks water, which is they obtain water through the use of the xylem and phloem, and also air or gases. Is it obtained? The air is obtained from atmosphere, reactions of roots, microbes, and chemicals in the soil. Yes, during the process of photosynthesis, the air is what is obtained. You know, as human being, when you breathe in, as an human, when you breathe in oxygen. But when you breathe out carbon dioxide. There is something called gaseous exchange between you and the plant in your environment. So the plants also, the air quantity is also developed, or should I say derived from the gaseous exchange. Now, living organisms. The living organisms in plants are both big worms, insects, and small, which is microbes, which are examples of microbes and bacteria and all. Well, we know when we're talking about big organisms, just like that, we can talk about worms, insects, and so on and so forth. The presence of these insects, worms, also help with the soil, also helps the soil element. Now let's talk about the soil components. The soil is made up of the following components, which is mineral matter, just like as I've said earlier, organic matter, soil, water, soil, air. Now, let us explain the term mineral matter. This accounts for majority of the solid in most soil. It contains of stone, gravel, sand, silt, and clay. It is about 40% of the total volume of the soil. Yes, not everything is greenish in its looking. When we keep on digging, when we keep on digging the soil, you will discover that some solid materials can be discovered, which isn't another material, which is also a part of the soil. Some of them can be stones, gravel, sand, silt, and clay, and it is about 40% of the total volume of the soil. And let us talk about organic matter. Soil consists of rocks, particles, and certain amount of organic material called humus. Now, humus refers to the dead decay of leaves, roots of plants, residue of crops, and animal dungs. It is about 5% of the total volume of the soil, which I've explained earlier. Now, soil water. Soil water refers to the water in the soil, which is obtained from rainfall, irrigation, and underground water. There are 4 forms of soil water. These are gravitational water, capillary water, hygroscopic water, and field capacity. And I hope you guys remember that. Now, soil water represents about 25% of the total volume of the soil. Now, let's talk about the soil air. This refers to the gases present in the soil, which is e.g. nitrogen, ammonia, etc., and so on and so forth. The percentage of air is about 25% of the total volume of the soil, which is the mineral matter is 45%, and then the organic matter is of 5%, which is 45 plus 5 is 50, and soil water, which is 25, makes it 75 plus 25, which is for soil air, making it 100. These are the composition of soil. These are what makes up the soil. Now let's talk about the properties of the soil. Physical properties of the soil. We have something. There are a lot of properties, physical properties, of the soil, which have been taken into notice, and some that haven't been taken into notice. Number 1 is texture. Texture. Now, the texture refers to the relative proportions of particles and various sizes, such as sand, silt, and clay in the soil. Properties that are influenced by soil texture include porosity, permeability, infiltration, shrink swell rate, water holding capacity, and susceptibility to erosion. Now, the texture of the soil also protects the soil from, or should I say, delay the soil from erosion sometimes. It delays the process of erosion with the soil, which means it slows down soil's erosion sometimes. And also, yeah, it also helps the soil texture help us in knowing our soil, the types of soil and their texture, how to use them, and how to make things out of them. Let us talk about the second physical structure, which is the second physical property, which is structure. Now, the term texture is used in reference to the size of individual soil particles, but when the arrangement of the particle is considered, the term structure is used. Now, for example, we all know about we all know that as an human being, there are some things that makes us humans, just like our bones, the position of our bones. All those are put into consideration before we are called human beings. We can stand when we are mammals. This makes us humans, but most of all is our human structure. Same thing, the soil is also having a structure, but when the texture is being put into consideration, that is when we use the term structure. Now, what is this structure? All right, put it down. Structure refers to the aggregation of primary soil particles, sand, silt, and clay into compound particles. I repeat, structure refers to the aggregation of primary soil particles, which is the sand, silt, and clay, into compound particles, or cluster of primary particles which are separated by the adjoining aggregate by surfaces of weakness. Just as I've said, we have to know what to use it for, how we can use it. Now, they can also be defined by their structure. Just as an human being can't survive in a volcano because it isn't meant to be there. But a rock might survive around a volcano, but not in the volcano. But an human being cannot survive around the volcano and in the volcano, which means its structure, it isn't built for that kind of thing. Now let's talk about the classes of soil structure. Number one, shape and arrangement of beds, which are the types. Now let's talk about number one, which is platy. Now, beds are flanking one atop the other, 1 to 10 millimeter thick, found in the high horizon of soil forest and lake sedimentation. And number two is prismatic and columnar. Prism-like beds along in the vertical dimension 10 to 100 millimeter wide. Prismatic beds have flat tops. Columnar beds have rounded tops. Tend to form in the B horizon in high sodium soil where clay is accumulated. Now let's talk about the angular and subangular. Now blocky beds are imperfect cubes. 5 to 50 millimeter angular have sharp edges. Subangular have rounded edges, and it tends to form in the B horizon where clay is accumulated and indicates poor water penetration. Granular and crumb. Spheroid beds in polyhedrons. 1 to 10 millimeter, often found in the A horizon in the presence of organic matter. Crumb beds are more porous and are considered ideal. Now let's talk about the classes. The classes is, when we're talking about the classes, we're talking about the size of beds whose range depend upon the above type, which is number one, very fine or very thin. It is 1 millimeter platy and spherical, 5 millimeter blocky, and 10 millimeter prism-like. Fine or thin, 1 to 2 millimeter platy and spherical, and 5 to 10 millimeter blocky, 10 to 20 millimeter prism-like. Number 3 is medium. Number 3 is medium. 2 to 5 millimeter platy, granular, 10 to 20 millimeter blocky, 20 to 50 prism-like. Number 4 is coarse or thick, 5 to 10 millimeter plating, granular, 20 to 50 millimeter blocky, 50 to 100 millimeter prism-like, very coarse or very thick, 10 millimeter platy and also granular, 50 millimeter blocky and 100 millimeter prism-like. Grades. Now, this grade is a measure of the degree of development or cementation within the beds that result in their strength and stability. We can just call these grades as ratings. Number 1, weak. Weak cementation allows beds to fall apart into the three textural constituents, which is sand, silt, and clay. Now, when the cementation is weak, it allows beds to fall apart into three textural constituents, which are known as soil, silt, and clay. Now, 2, moderate. Beds are not distinct in undisturbed soil, but when removed, they break into aggregates. Some broken aggregates and little unaggregated material. This is considered ideal. Number 3 is strong. Beds are distinct before removal from the profile and do not break apart easily. And structureless, which is number 4. Soil is entirely cemented together in one great mass, such as slabs of clay, or no cementation at all, such as with sand. Let's talk about the density. Density is the weight per unit volume of an object. Density is the weight per unit volume of an object. Particle density is equal to the mass of solid particles divided by the volume of solid particles. It is the density of only the mineral particles that makes up of a soil. That is, it excludes pore space and organic material. Consistence. Consistence is the resistance of a soil to deformation or rupture and is determined by the cohesive and adhesive properties of the soil mass. Consistency is the ability of soil to stick together or to stick to itself to other objects, which is the cohesion and adhesion respectively, and its ability to resist deformation and rupture. Now, consistency also gives an indication of the soil texture. Consistency is described for 3 moisture levels. Number 1 is wet soil, which is non-sticky, slightly sticky, sticky, very sticky, non-plastic, slightly plastic, plastic, and very plastic. And number 2 is moist soil. Loose, very variable, variable, firm, very firm, extremely firm. Dry soil. Loose, soft, slightly hard. Hard, very hard, extremely hard. Porosity. Particle density can be determined by using gravity bottle technique, and bulk density by taking soil core samples of known volume in a field and determining the even dry weight. Pore space is that part of the bulk volume of soil that is not occupied by either mineral or organic matter but is open space occupied by either gases or water. Ideally, the total pore space should be 50% of the soil volume. Pore space also allows the movement and storage of water and dissolved nutrients. There are four categories of pores. We have very fine pores, medium pores, coarse pores. Now let's talk about the temperature. Soil temperature depends on the ratio of the energy absorbed to that lost. Soil has a temperature range between 20 to 60 degrees Celsius. Soil temperature regulates seed germination, plant and root growth, and availability of nutrients. Yes, the temperature, just as we know, which is our common or general knowledge, helps in germination, plant and root growth, and availability of nutrients. And let's talk about the color. Soil color gives an indication of the various processes going on in the soil, as well as the types of minerals in the soil. And sometimes when the color of the soil changes, it lets us in on what is going on in the soil. Or for example, the red color in the soil is due to the abundance of iron oxide under oxidized condition, which is well drainage in the soil. Dark color is generally due to accumulation of highly decayed organic material. And yellow color is due to hydrated iron oxide and hydroxide. Black nodules are due to manganese oxides. Mottling and glean are associated with poor drainage and or high water table. Now let's talk about the chemical properties of the soil. Chemical properties of the soil. Number one, soil reaction, which is soil pH or acidity. Number two is soil exchange basis. And number three is cation exchange capacity, which can also be called CEC. Now, the soil reaction, this refers to the acidity or alkalinity of the soil. And when we are talking about the soil reaction, believe it or not, the soil is having a lot of elements, just like you do. Now there are some micro and macro elements in the soil which helps its reaction, which is also called the acidity or alkalinity of the soil. Now, when we say soil pH, this is the measure of acidity or neutrality of a soil. While the soil acidity is the concentration of hydrogen ions in the soil, while the soil alkalinity is referring to the concentration of hydrogen ions in the soil. Now let's talk about the soil exchange bases. This includes calcium, potassium, magnesium, and sodium and ammonium held in the negative exchange sites of the clay-humus complex in the soil. Now, what is the cation exchange capacity? This is the capacity of the soil to hold nutrient cations and exchangeable hydrogen. Now, what are the causes of soil acidity? What can be the causes of soil acidity? Organic material decomposition. Just like I said earlier, there are some elements in the soil which helps in the acidity of the soil, and some of these elements are again from the organic matter decomposition, and some of them are again from crop removal. Now, this crop removal can also be termed as mixed cropping. Or when you are ready as a farmer, when you are ready to harvest your crops. Now, number 3 is plant root exudes. Number 4 is presence of acidic parent materials. And number 5 is rainwater, which is the weak solution of carbonic acid. Now, what is the correction of soil acidity? Number 1 is wood ash, gypsum, GYPSUM. 3 is quicklime or calcium oxide. Number 4 is dolomite, which is calcite. And number 5 is limestone, calcium carbonate. Now, what is the importance of the soil? I'm going to list 5 importance of the soil. Soil provides required nutrients for growth and development for plants. Man plants his crops on the soil. That is number 2. And number 3, man also builds his shelter on the soil, just as I've said. And as an human being, it is impossible for you to live in the water because you are supposed to live on the land. And if we should look at the ratings, or should I say the calculation of this word, almost 70% is covered by water, but the 30% is dominated by man, or should I say plants and animals and other terrestrial animals. Now, soil also serves as habitat for some animals and useful microorganisms. Number 5, food and other biomass production. Food and other biomass production are also gotten through the soil, environmental interaction, storage, filtering, and transformation. And soil can also act as source of raw materials, physical and cultural heritage. Platform for man-made structure, which is buildings, highways, industrial development, and so on and so forth. I believe today we've known more about the composition of soil and some things about soil. Don't forget, this is Open Faith Academy, and this lecture is for S.S.2 and 3. God bless you. Remain blessed. Remember, in God we trust. Amen.